now that we have had a brief discussion on what is climate change and what are the various factors that are leading to climate change, we also saw some of the data with respect to climate change. Now we'll come to the main topic of climate change. Basically, we'll call it global warming. See, just try to understand why I am not using the term climate change and I'm using the term global warming. Mainly because global warming is mainly associated with human activities. The component of climate change which is associated with human activities, that part is called as global warming. So that's why most of our discussions that we'll do, you try to understand when I say climate change, it includes both natural as well as anthropogenic factors. When I say global warming only includes the anthropogenic factors, right? So please understand that. Now, so what exactly, that's why when we say global warming, what is it? You can say that it is the average increase in global temperatures due to human activities in past 200 to 300 years. So this is what we mean when we say global warming. Now, what are the various causes of global warming? And here we'll discuss all the major factors that are all the time in news. First, we will start with greenhouse effect. The most important cause when we say for global warming, the first would be greenhouse effect. Then we'll discuss the change in land use pattern, or in other terms, deforestation. And after we have discussed these two, we'll discuss all the other factors, but these two will become the most important factors that we need to discuss. Now, when we say greenhouse effect, what is the meaning of greenhouse effect? There are two terms that you'll always see. One is greenhouse effect and the other one is greenhouse gases. What do we mean by greenhouse effect and what are greenhouse gases? Let's try to understand that. Now, when we say greenhouse effect, try to understand something, that the average surface temperature of the earth is maintained by a balance of various forms of solar and terrestrial radiation. You have something called as solar radiation and you have something called as terrestrial radiation. Now, what is the difference between terrestrial radiation and solar radiation? So, normally the solar radiations are basically short wave. What do we mean by short wave? We mean that the radiation that is coming from the sun have a very high frequency and they have a very short wavelength. They have high frequency and they have short wavelength. And when we talk about the terrestrial radiation have lower frequency and they have long wavelength. So what do we mean here? When we say short wavelength, normally we mean the part of the wavelength that is nearer to the visible portion of the electromagnetic spectrum. And the long wavelength, that is the terrestrial radiation, this is basically near the infrared region of the spectrum. It is near the infrared region of the spectrum. Now, how does this matter? What happens is the amount of solar radiation that is absorbed by the Earth's surface is only a very small portion or very small fraction of the total solar radiation that enters the atmosphere. So what happens is for every 100 units of incoming solar radiation, generally 30 units are reflected back into space. It can happen either by the action of clouds due to the atmosphere or other reflective regions of the Earth's surface. Now the reflective capacity, this reflective capacity that the Earth has, this is called as planetary albedo. I'm sure that you have come across this term in your geography classes as well. So planetary albedo, please remember this term because we will make use of this particular term as we go along with our discussion. So what do we mean by albedo? The reflective capacity of the Earth. What is the reflective capacity? The fact that for every 100 units of incoming radiation, roughly 30 units of radiation are reflected back, right? This is called as planetary albedo. Now, this planetary albedo basically does not remain fixed. It depends on how much radiation we are receiving over a course of day, over a course of decade, over a course of 1,000 years, we can do a study on albedo on all these, so it will definitely not remain fixed over time. So the 70 units of the solar radiation that is not reflected, this may be absorbed by the atmosphere, the clouds, or the surface. So now, if there is no further complication, in order to maintain an equilibrium, a thermodynamic equilibrium, what do we mean by thermodynamic equilibrium? The fact that whatever be the amount of heat that is being received by the earth, the same amount of heat also needs to go back from the earth, so that the net effect does not change. So if there is an absence of any further complication, in order to maintain the thermodynamic equilibrium, the earth's surface and the atmosphere must radiate these same units back into the space. Now, up to this part, it's fairly simple, and this is something which is natural and has been happening ever since the earth has existed. But this gets complicated. So if you look at this particular diagram, you would understand that what happens is that we are receiving the solar radiation, and this solar radiation has to reflect back to the space. But since there are clouds, there are some carbon dioxide, etc., these can absorb some of the solar radiation, and this is what is done by the greenhouse gases. And when these greenhouse gases trap some of these radiations, just understand that this radiation, when we are talking about the radiation or the wave coming from the sun, this basically is the source of heat. So when some of these radiations do not escape back into the space, it means that some of the heat is being trapped. And this trapping of heat is very, very important for the existence of the earth itself. So when you see greenhouse effect, just understand that greenhouse effect is not a bad word. Greenhouse effect due to human activities is something which is bad. So here, whatever we are discussing until now, it's just the natural process. So there is no harm in having this greenhouse effect. But the problem arises when we take into account the greenhouse effect which is caused by human activities. So what are these greenhouse gases? You have carbon dioxide, you have methane, you have nitrous oxide. So what these greenhouse gases do is that they absorb some of the infrared radiations which are produced by Earth's surface. Now, because of this absorption, some fraction of the original 70 units does not directly escape into the space. The net effect of absorption by greenhouse gases is to increase the total amount of radiation emitted downward towards the surface and the lower atmosphere. So what is happening is that the Earth's energy budget is getting complicated, and this is happening because of the greenhouse effect. What are greenhouse effect? Greenhouse effect is coming from the greenhouse gases, and these are gases which have some property. What is this property? The property is that they absorb some of the infrared radiations produced by the Earth's surface. Now, when they do that, with this absorption, obviously the amount of heat that is trapped in the earth, or you can say at the surface of the earth or the lower atmosphere of the earth, this is increasing. So it is more heated than it would normally be. Now, because the greenhouse effect emit the same amount of radiation they absorb, and because this radiation is emitted equally in all the directions, what happens is, why we are saying all the directions? Because normally, if this is the earth, the sun's radiation would come like this and go like this, right? But since there is a presence of greenhouse gases in this part of the atmosphere, what happens is this is coming. Now, this is not going back. Some of it is being reflected back. So from here, if I take this point here, basically this radiation will go in all the directions. So since it is going in all the directions, it means that some of the heat is actually coming back. Some of the heat is actually coming back, and that's why we are saying that the net effect of the absorption of heat by greenhouse gases is to increase the total amount of radiation that is emitted downward towards the surface of the earth. And not only the surface of the earth, but also the lower atmosphere. I hope that this point is clear. Now, what happens is that to maintain the equilibrium, the Earth's surface and the lower atmosphere would actually emit more radiation than the original 70 units. So, as a consequence of this, the surface temperature will become higher. Now, this process basically is not quite the same as what happens in true greenhouse effect, but the effect is similar. The presence of greenhouse gases in the atmosphere leads to warming of the surface and lower part of the atmosphere. And also in the upper part of the atmosphere, there will be, you can say, relatively cooling effect in the upper part of the atmosphere relative to what is expected in the absence of greenhouse gases. So it leads to the warming of the surface and the lower part of the atmosphere relative to what would be expected in the in the absence of greenhouse gases. So if you look at this diagram, this is what we were trying to depict, that you have incoming solar radiation to the earth. Now after this, the reflection that happens, it happens in all the directions, right? Reflection will happen in all the directions. So that's why, since it is happening in all the directions, some of the heat will get trapped and it will not go out of the atmosphere into the space. But one thing, just try to understand that there is a need to distinguish between what is natural greenhouse effect and what is enhanced greenhouse effect. So the enhanced greenhouse effect mainly is associated with the human activities. Natural greenhouse effect is associated with the surface warming properties that we just discussed. The surface warming properties of the greenhouse gases which naturally exist. For example, if you talk about the Earth's atmosphere, especially water vapor, carbon dioxide and methane, these occur naturally. So existence of this effect is actually accepted by all the scientists. Now, the thing is, you have to understand here that in the absence of natural greenhouse effect, the total temperature of the earth, the average temperature of the earth would approximately be 33 degrees lesser. It will be lesser by 33 degrees Celsius, and that's why it will be much colder than what we have today. So the natural effect of greenhouse gases are very important for the existence of life on earth, existence of humans at least. So if there were no greenhouse gases, the average temperature would have been lower by 33 degrees Celsius. Now, and that's why you can say that the earth would be frozen and likely it will become a very uninhabitable planet. So the controversy is not around natural greenhouse effect, but the enhanced greenhouse effect, which is associated with the increased concentration of the greenhouse gases which have happened due to the industrialization and other human activities. Now, in particular, if we talk about the burning of fossil fuels raises the concentration of the major greenhouse gases in the atmosphere, and these higher concentrations have the potential to warm the atmosphere by several degrees Celsius. So this is the basic difference between natural and the enhanced greenhouse effect. Now we'll discuss all the greenhouse gases. We'll discuss carbon dioxide, methane, water vapor, nitrous oxides, etc. But before that, there is one concept that I want you to be introduced to, and that is radiative forcing. So now, until now, what have we discussed? We have discussed that heat is being trapped, and trapping of heat is also essential for the existence of life on earth. Now just imagine, just try to understand how exactly can we trap this heat. So the temperature of the earth's surface and the lower atmosphere would be modified in three ways, right? What would be the three ways? One, through a net increase in the solar radiation entering the top of the earth's surface. Apart from that, through a change in the fraction of radiation reaching the surface. Or the third, through a change in the concentration of greenhouse gases in the atmosphere. What I am trying to say is that in how many ways can we increase the amount of heat that is being received by the surface of the earth? One thing that I can do is I can increase the amount of solar radiation that is reaching the earth. But doing that is not possible, right? Second, what I can do is that there can be a change in the fraction of the heat that is being trapped by the earth. Now naturally even that cannot happen. It is very much a natural process, and that's why it is a fixed number that how much would be reflected back and how much would be absorbed. The third way in which it can be increased, the amount of heat can be increased, is by increasing the concentration of greenhouse gases or increasing the amount of greenhouse gases in the atmosphere. Because greenhouse gases are trapping the heat, you increase the amount of greenhouse gases, more heat will be trapped. Correct? This can happen. So in these three ways, what can happen is we can increase the amount of heat or increase the amount of radiation that is with the surface of the earth or lies in the lower part of the atmosphere. Now, this basically is called as radiative forcing. What is radiative forcing? It is a measure of the influence a given climatic factor has on the amount of downward directed radiant energy impinging upon Earth's surface. So what do I mean? And this basically was a definition which was given by IPCC. So IPCC, please remember that IPCC is the most important organization with respect to climate change. All the reports that are being published by IPCC are going to be very, very important. Just in October 2018, there was one report that came which was submitted by IPCC. Before that, there is the fourth assessment report and there is the fifth assessment report, both of which was launched by IPCC, one in 2007 and one in 2014. Please remember that these two are going to be very, very, very important. If you just have a look at the previous year question papers, you will see that there is one question just a couple of years back where they had asked about cryosphere, the effect of climate change on cryosphere, and there was a particular report in this fifth assessment report on the effect of climate change on cryosphere. So directly the things are being picked from these reports and being asked in the mains or prelims examination. So please remember that any report that is being published by IPCC will become very, very important for your examination, both in prelims as well as in the mains examination, right? So what is radiative forcing? It is the measure of the influence that a given climatic factor would have on the amount of downward directed radiative energy imposing upon Earth's surface. What we are saying is that there are two things that can happen. Let's say if I am talking about a climatic factor, I have a climatic factor. This climatic factor can have influence on the climate in two ways. Either it would make it colder or it would make it warmer, right? These are the two things that can happen. So if it makes it colder, in that case it is called as negative radiative forcing, and if it makes it warmer, in that case it is called as positive radiative forcing. So this is a difference that you have. So either it will be a negative radiative forcing or it will be a positive radiative forcing. If it is positive, in that case it means that this climatic factor is making the climate warmer, and if we say there is a negative radiative forcing, in that case we mean that it is making the climate of the earth colder. So please understand this. So basically that's why we are saying that we are trying to measure the influence that a climatic factor has, and this would be called as radiative forcing. Now if you look at this particular diagram, you will have an understanding of what is positive and what is negative forcing. So if we just have a look here, if you see the first one, that is the influence of carbon dioxide. The influence of carbon dioxide, if you see, is basically a positive radiative forcing. I can say positive RF. Methane also has a positive RF, correct? Similarly, you would see that halogenated gases also have positive RF. Same with nitrous oxide. Then if we talk about the negative radiative forcing, you would see that normally it is happening due to the action of aerosols. What are aerosols? We'll have a discussion on that also. But basically you have to understand that aerosols have a negative radiative forcing. Now, a very small amount of positive radiative forcing is also happening due to change in energy from the sun. But if you look at the net, these are the things which is happening through due to human activities, and this small component is natural. So if you look at the net total due to human activities, we have such a huge amount of positive radiative forcing. What is the meaning of positive radiative forcing? The fact that it is making our climate warmer. So all these things have been seen, and this was another part of a report given by IPCC itself, that the total positive radiative forcing by human activities is very high. The negative forcing is negligible as compared to the positive forcing. Now, one more thing that we should understand, that when we say climatic factors are divided between those which are caused by human activities. For example, greenhouse gas emissions and aerosol emissions, etc. And apart from that, there are those which are caused by natural forces. For example, the sun's radiation. Now, then for each factor, there are some forcing values which are calculated for the time period between 1750 and the present day. And when we do that, when we look at the total effect, this is called as positive forcing, and this is what we see as positive forcing. And similarly, negative forcing is contributed by the factors which have led to the cooling of Earth's surface. So human activity has influenced the global surface temperature, and it has done so by changing the radiative balance governing the Earth on various time scales. And various time scales, I am talking about the various geological time scales. And of course, the most important and profound anthropogenic influence is the elevation in the concentration of greenhouse gases that have happened in the atmosphere. So we have changed the natural radiative forcing of the Earth by increasing the amount of concentration of greenhouse gases, changing the concentration of aerosols, then by deforestation or changing the land use pattern, land cover of Earth's surface, and also you can say due to the action of ozone. We'll discuss that part as well. So first, let's start with the action of greenhouse gases. So greenhouse gases, most importantly, are the ones which are listed out here: nitrous oxide, water vapor, methane, and carbon dioxide. These are the four most important greenhouse gases. Now, we'll have a discussion on all the greenhouse gases one by one. First of all, we have to understand that the greenhouse gases warm the surface of the Earth. I'm reiterating myself, I know, but you have to understand this. By increasing the net downward long wave radiation that is reaching the surface. We discussed what is long wave and what is short wave. The relationship between the atmospheric concentration of greenhouse gases and the associated positive forcing of the surface is different for each gas. There is a very complicated relation that exists between the chemical properties of greenhouse gases and the relative amount of long wave radiation that each one of them can absorb. So that's why we'll have a discussion on behavior of each one of these greenhouse gases. So to start with, the first one is water vapor. So water vapor basically is the most potent. You should understand this, that it is the most potent of all the greenhouse gases in the Earth's atmosphere, but its behavior normally is very different from other greenhouse gases. The primary role of water vapor is not as a direct agent, but rather as a climate feedback. What do we mean by climate feedback? That it is basically as a response within the climate system that influences the activity of the entire climate. And this distinction arises from the fact that the amount of water vapor in the atmosphere, in general, it cannot be directly modified by human behavior or human activities, but instead it is set by the air temperature. The warmer is the surface, the greater evaporation rate of water will happen from the surface. And that's why, as a result, you can say that increased evaporation leads to a greater concentration of water vapor in the lower atmosphere, which is capable of absorbing long wave radiation, and it starts to emit it downwards. So what I am saying is that increased evaporation leads to a greater concentration of the water vapor in the lower atmosphere, and this would be capable of absorbing long wave radiation. So if you remember, we talked about the fact that long wave radiation comes back from the terrestrial radiation. It is the reflected radiation that we have, and since it is infrared, just always remember this fact whenever we talk about the infrared radiation is always associated with heat. And since these are infrared radiations, these are being trapped by water vapor, it would increase the general temperature of the surface and the lower atmosphere. I hope I'm clear. Now, the next gas that we need to see is carbon dioxide. And carbon dioxide as a greenhouse gas is the most important gas that we need to discuss. Of all the greenhouse gases, carbon dioxide is the most significant. The natural sources, if we talk about for carbon dioxide, they include outgassing from the volcanoes, the combustion and natural decay of organic matter, and respiration by aerobic organisms. And these set of sources that we have, these basically have their sinks. So these sources are balanced by a set of physical, chemical or biological processes called as sinks that tend to remove carbon dioxide from the atmosphere. Now, there are significant natural sinks that we have. You can talk about the terrestrial vegetation, which basically through the process of photosynthesis, they are the ones which are absorbing carbon dioxide, right? So this happens naturally. The problem arises when we talk about the human activities, because if you talk about the natural carbon cycle, you know that carbon is transported in various forms through the atmosphere, through water and other geological formations. So one, for example, primary pathway for the exchange of carbon dioxide takes place between the atmosphere and the oceans. So what happens is a fraction of carbon dioxide, it combines with water. So carbon dioxide will combine with water, and in that case it leads to the formation of carbonic acid. It leads to the formation of carbonic acid, and subsequently hydrogen from this is lost and you get the formation of carbonates and bicarbonates. So these formations happen, and this basically gets buried inside the earth and would be released as carbon dioxide through volcanic outgassing. So this is one way. Apart from that, carbon dioxide also exchanges through photosynthesis, as we just discussed, and also through the respiration in animals. One more factor that we need to discuss are the dead and decaying organic matter, where they may ferment and release carbon dioxide, and they release methane as well, which basically would be incorporated into sedimentary rocks, where this is again converted into a fossil fuel and gets buried inside the earth. Now this is the natural process, but what we do is we have started to take out this fossil fuel, and by taking out this fossil fuel, the carbon dioxide which should have remained packed inside the surface of the earth, that has come to the surface. The burning of hydrocarbon fuels basically, or these fossil fuels, becomes the main source of carbon dioxide. Not only carbon dioxide but also water vapor, which comes out by the burning of fossil fuels. Now the problem is the anthropogenic pathways that we are providing, it is much faster than the geochemical pathway, and that's why as a result it has a major impact on the composition and temperature of the atmosphere, because with the natural process so much of carbon dioxide would not have been added, and since this extra amount of carbon dioxide is being added, this is basically leading to warming of the atmosphere. Now when we talk about the human activities have increased the atmospheric concentration of carbon dioxide primarily through the burning of fossil fuels, as we discussed, and which basically comes from transportation or heating and generation of electric power, and also up to an extent through the production of cement. If you talk about the other anthropogenic sources, they include the burning of forest and clearing of land, Basically, we are talking about deforestation. Anthropogenic emissions currently account for annual release of 7 gigatons or 7 billion tons of carbon into the atmosphere. So this is the major problem, because these anthropogenic emissions are equal to approximately 3% of the total emissions of carbon dioxide by natural sources, and this amplified carbon load from human activities far exceeds the offsetting capacity of the natural sink. So consequently, what happens is carbon dioxide accumulates in the atmosphere at the average rate of 1.4 parts per million by volume every year, and this has been observed between 1959 to 2006, and between 2007 and 2017 the data says that the rate of carbon dioxide accumulation has increased roughly to 2.25 parts per million by volume every year. So that's why if we take the whole set of data into account, the growth of atmospheric concentration has been very linear in nature. But this is something which will change, because some of the carbon sinks, for example oceans, they can become source in future. And if they become source, this will lead to a situation where the concentration of atmospheric carbon dioxide builds at an exponential rate. So this is a major problem that we might face in future. Now, the natural background level of carbon dioxide, it varies according to the time scales in the millions of years. How? Because there are slow changes in the outgassing which happens through volcanic activities. For example, roughly 100 million years ago, when you had the Cretaceous period. What is Cretaceous period? Cretaceous period is the geological period that lies between 145 to 66 million years ago. So in this period, what has been observed is that the CO2 concentration levels, carbon dioxide concentration levels, have been several times higher than they are today. Approximately, you can say it was 2000 parts per million. But over past 7 lakh years, the concentration of carbon dioxide varied over a far smaller range, that is between 180 to 300 parts per million. But in 2017, the carbon dioxide levels were seen to be 403 parts per million, which approximately is 44% above the natural background level that existed at the beginning of Industrial Revolution. So at the beginning of Industrial Revolution, as we already discussed, it was approximately 280 parts per million. So according to the measurements, this level is believed to be the highest in the last 8 lakh years. And that's why some of the evidence that have been collected by the scientists, this even says that it might have been the highest in last 50 lakh years, not even just 8 lakh years. So the radiative forcing that is caused by carbon dioxide, that basically varies in approximately logarithmic fashion with concentration of the gas in the atmosphere. What do we mean by logarithmic fashion? If you look at this particular diagram, this is the log scale. So this is the way in which the radiative forcing, and this basically is carbon dioxide concentration. So when you start to increase the carbon dioxide concentration, basically 4 means 400 parts per million. So this is how we are going. Now, as you start to increase the carbon dioxide level, you see that there is an increase in the radiative forcing as well. And since there is an increase in radiative forcing because of increase in concentration of carbon dioxide, that's why it will definitely lead to higher temperatures. So in very simple terms, higher concentration of carbon dioxide would mean higher temperatures, correct? And this means that this is positive radiative forcing. So what happens is that until a point, whatever increase in carbon dioxide levels are happening or increase in greenhouse gases are happening, it can be reversed. But there will come a time, if you keep on increasing the levels of concentration of carbon dioxide in such a manner, there will come a time when it will become irreversible. And after that point, you can take any measure you want. You can reduce the amount of fossil fuel uses, you can reduce the amount of effluents from coming out of your vehicles, you can do anything you want, but it will become an irreversible process. And that is the catastrophe that we are heading towards. And this is not very far away, because we are already at 403 as per the studies done in 2017. If it crosses 560, if it is crossing 560 parts per million, it will become irreversible. So we are not very far away from doom. If you think that climate change is not something that present generation needs to think about and it will be something for the future generations to think about, that's not true. Same thing we used to think about ozone layer depletion in 1960s. And in 1980s, we saw such a huge problem that all of a sudden the entire world had to wake up. And then we had the Montreal Protocol, which led to at least the decrease in amount of chlorofluorocarbons and decrease in amount of the ozone hole that was caused. We'll have a discussion on what is ozone hole and what are chlorofluorocarbons. But you have to understand that climate change until a point would be reversible. But there will come a point when you would tip the balance and it will become irreversible in nature. Right? So coming back to the discussion of carbon dioxide. So at current rate of fossil fuel use, a doubling of carbon dioxide concentrations over pre-industrial levels is expected to take place by the middle of 21st century itself, when the concentration of carbon dioxide are projected to reach 560 parts per million. So you have to understand that this logarithmic relationship that we have predicts that the surface warming potential will rise by roughly the same amount for every doubling of concentration of carbon dioxide. So at the current rate, by mid of 21st century, we will reach the concentration of 560 parts per million, which would have a catastrophic effect on everything around. Next greenhouse gas that we have is methane. So methane is the second most important greenhouse gas, and it is more potent than carbon dioxide. Please remember that it is more potent than carbon dioxide because the radiative forcing produced per molecule is greater. But at the same time, that you have to note that it exists in far lower concentration than carbon dioxide in the atmosphere, and its concentration by volume in the atmosphere are generally measured in parts per billion. In case of carbon dioxide, we were measuring in parts per million. Here we are measuring in parts per billion. And secondly, it also has a considerably shorter residence time in the atmosphere than carbon dioxide. So although it would be more potent than carbon dioxide, but the fact is also that the concentration is much lower as compared to carbon dioxide, and its residence time in the atmosphere as compared to carbon dioxide is very less. For example, the residence time for methane is roughly 10 years as compared to carbon dioxide, for which it could be hundreds of years. So this is the difference between methane and carbon dioxide. Now, if we talk about the natural sources of methane, it would be wetlands, or apart from that, the methane oxidizing bacteria that basically feed on the organic matter which are consumed by termites, etc. Apart from that, you have volcanoes, you have seepage vents of the seafloor in the regions which are rich in organic sediments. And apart from that, you have methane hydrates. You have methane hydrates which are trapped along the continental shelf of the ocean and in the polar regions. So the primary natural sink, if we talk about, in that case, it is the atmosphere itself, where methane readily reacts with the hydroxyl radical which is within the troposphere to form carbon dioxide and water vapor. When methane reaches stratosphere, it is destroyed. Now, apart from that, another natural sink is soil, where methane is oxidized by the action of bacteria. Now, as was the case for carbon dioxide, human activity is also increasing the methane concentration much faster than it can offset by natural sink. The anthropogenic sources currently account for approximately 70% of the annual emissions that happen. Now, the major anthropogenic sources of atmospheric methane are rice cultivation, livestock farming, burning of coal and natural gas, combustion of biogas, and the decomposition of organic matter in the landfill. Correct? So, these are few of the facts about methane. Then, after that, we have surface level ozone. Now, just understand that there are two kinds of ozone that we talk about. One which is at the surface, and the other which is in the stratosphere. So there is a difference between the two. The one which is at the surface is actually also called as bad ozone many a times, and the one in the atmosphere is called as good ozone. And there is a reason why we call it as bad ozone or good ozone. Surface ozone is a result of air pollution, and the one which is in the stratosphere, this is naturally occurring, so there is no anthropogenic factor that is associated with the stratospheric or good ozone. So the primary anthropogenic sources of ozone would be photochemical reactions that involve the atmospheric pollutant, which is carbon monoxide. So carbon monoxide, action of carbon monoxide, we already have dealt with in air pollution. You can have a reference of that from there. But just understand that there is a difference between the two. One is bad ozone or surface level ozone, or also called as tropospheric ozone. And the other one becomes stratospheric ozone. Correct? Then you have nitrous oxides and the fluorinated gases. Now, nitrous oxides and fluorinated gases, or something which is also called as halocarbons, now they also have some significance with respect to greenhouse effect. Halocarbons includes sulfur hexafluoride. Apart from that, you have various hydrofluorides and also perfluorocarbons. Perfluorocarbons basically, you can say, have the formula of CXFY. Basically, you have only carbon and fluorine. So if you have a compound which has only carbon and fluorine, in that case you call it perfluorocarbon. So this is another factor, and apart from that, nitrous oxides have small background concentration due to natural biological reactions in the soil and water, whereas the fluorinated gases owe their existence almost entirely to the industrial sources. So these two also not a very significant, not as significant as carbon dioxide or methane or water vapor, but still you have these two also which are significant as long as you are discussing greenhouse gases.